Look at this marvelous exoplanet. It resembles a giant eyeball hanging out there in space. But it isn't the coolest thing about it. This distant world, identified in 2017, is one of the most promising places for finding life outside the solar system. And recently it has become even more promising and way weirder. But first things first. The exoplanet called LHS 1140b shows signs of having a global ocean capped in ice. It's that very iris, a huge region around 2,500 miles across, which is constantly gazing at its host star. The planet has a radius of 1.73 times the radius of Earth, and it's 5.6 times as massive as our home planet. In other words, it's bigger than Earth, but still small enough to be a potential terrestrial world. LHS 1140b also orbits much more closely to its star than Earth does. It needs just around 25 days to complete an entire orbit. If the star were similar to our Sun, such a distance would definitely be too close for life to appear on the planet. But instead, it's a cool and dim red dwarf. That's why the exoplanet lies in the habitable zone of its star, where it's not so cold that all surface water would freeze, and not so hot that this water would steam away. And since water is a prerequisite for life, there's a chance that we might once discover some signs of life on this planet. But even so, such close proximity might mean that the exoplanet is tidally locked to its star, so that the same side is always facing the star. It's the same phenomenon you can see with Earth and the Moon. That's why we never see our natural satellite's far side. Being in a habitable zone doesn't automatically provide a planet with all the necessary conditions for the development of life. To learn more about the conditions on the planet, we need to sneak a peek into its atmosphere. If it has one, that is. Luckily, we have the James Webb Space Telescope, which can help us with this task. The planetary system in question is relatively close to us, around 50 light-years away. It gives us a chance to collect detailed information about how light changes when the exoplanet passes between Earth and its parent star. Some of the starlight travels through the atmosphere of the planet. In the process, some wavelengths get amplified or absorbed by atoms in the atmosphere. We can determine which atoms are at work by observing which wavelengths are affected. Using this method, astronomers have managed to suggest the presence of nitrogen, which is the dominant ingredient of Earth's atmosphere. This element also suggests a secondary atmosphere, which forms after a planet's birth rather than with it. If LHS 1140b was more gaseous, like a tiny Jupiter, it would have a more hydrogen-rich atmosphere. Researchers also tried to figure out the density of the exoplanet. The result they got means that eyeball alien world isn't dense enough to be made entirely of rock. Considering its size, it might be either an ocean-covered water world or a mini Neptune. But speaking of the first option, this ocean-covered world is likely to be not what you imagine. The side facing away from the star might be cold enough to completely freeze over, and only the area directly facing the star would be warm enough to thaw, resulting in a world looking like a creepy eyeball hovering in space. At the same time, that melted patch could heat up to 68 degrees F on the surface, which is warm enough for a well-developed marine ecosystem. At the moment, LHS 1140b looks like the most promising candidate for hosting life in our planetary neighborhood. Detecting an Earth-like atmosphere on such a planet is pushing James Webb's capabilities to its limits, but it is still feasible. Astronomers just need more time to examine this world. At least one more year of observations is needed to confirm whether the planet has an atmosphere, and 2 or 3 more to detect carbon dioxide.
We've discovered Kepler-22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler-22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler-22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler-22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler-22, the star of Kepler-22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler-22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler-22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler-22b is that it's about 15% closer to its star than we are to the Sun. If Kepler-22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler-22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler-22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler-22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler-22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler-22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler-22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler-22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler-22b. That would be awkward if it turns out to be a gas planet, or something like that. Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up. Our first destination is a gas giant called TRES-2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRES-2b orbits a yellow dwarf, a star similar to our sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES-2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES-2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blowtorched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the Sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems, but this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
So check this out. Astronomers have discovered an exoplanet they're calling Super Saturn. It's got rings over an AU wide. An AU is the astronomical unit, the distance between the Sun to the Earth. That's an incredibly huge ring system, hence its name. Super Saturn is being called Mamajek's object after the astronomer who led the team to whom we owe the discovery. Professor Eric Mamajek of Rochester University in New York found Super Saturn while scouring through data downloaded from wide-angle transit observations. WASP is the acronym for Wide Angle Search for Exoplanets. It's an ingenious project developed in the year 2000 by astronomers at Queen's University in Belfast, Northern Ireland, and St Andrews University in Scotland. Using 4 telescopes, the CCD video cameras on the scopes record the slight dimming of starlight caused by objects passing in front of stars. This is called the transit method of exoplanet detection. So, for example, the planet Venus transits across our view of the Sun every couple hundred years. A black dot, the silhouette of Venus, is visible, crossing in front of the Sun as Venus passes between our line of sight and the Sun. This tiny eclipse causes the amount of sunlight coming to Earth to be reduced by a minuscule amount, also known as teeny tiny. The same is true for all the stars in the Milky Way that have planets going around them. Exoplanetary transits in front of stars must be in direct line of sight with Earth for the starlight to be dim. Such transits do not occur very often. That's why thousands of stars must be looked at simultaneously for as long of a duration as possible, between 4 and 8 hours a night. WASP was created to stare continuously at as wide of a range of stars as possible. Maybe one of them would show an exoplanet transit. That translates into a lot of data being produced, about 40 gigabytes per viewing session. Computer scientists at Leicester University in England developed a computer program to store the data and generate photometric graphs of the light intensity of each star. Open University, also in England, joined the WASP project, took this data, and made it available for research by astronomers worldwide. The graphs of the intensity of starlight show that changes in its brightness are called light curves. These graphs have two axes. One is in the timeline axis, the other one is the intensity of light. As the object, considered an exoplanet, though it could also be a brown dwarf star, crosses in front of the star, the timeline axis keeps track of how swiftly it is moving. It tells us how close the object is to the star, while the brightness axis keeps track of how much the starlight dims. This way, we can find out how large the object is. Now, obviously, big objects will dim the light more and be easier to detect. At present, Earth-based equipment is not sensitive enough to measure the dimming caused by planets as small as Earth. Neptune's size and larger ones are the limit for WASP. However, the James Webb Space Telescope, which is now in operation, has a much greater sensitivity and will be able to resolve the transits of Earth-sized exoplanets. Now, I know you want me to get to Super Saturn, but there's something else you should be familiar with before we get there. If the exoplanet has an atmosphere, or, in the case of Super Saturn, a ring system, the starlight from the star the planet is transiting will shine through the atmosphere or ring system, and that can be detected too. The light curve will show less dimming in the photometric data, because not all the starlight is being blocked. Some light is still getting through the atmosphere or rings. This is important because it gives astronomers a reading of the atmosphere. The James Super Saturn orbits is J1407, a small, dim, sun-like pre-main sequence star of the 13th magnitude. Huh? Well, the human eye can only see stars to about the 6th magnitude, and each magnitude is 2.5 times dimmer than the previous one. So it's not an exceptional star, just another telescopic star out there in the Scorpius Centaur region of the night sky. J1407 is a young star that hasn't yet settled into its stable, long-duration phase. This is important because Super Saturn, officially J1407b, is showing signs of having a ring system in an early stage of development. Super Saturn's light curve was tucked away in the mountain of data from the Super WASP project. Professor Eric Mamajek and his associate Matthew Kenworthy of Leicester University studied the data thoroughly and produced a detailed report on it. Knowledge depends on good data. The horizontal axis of J1407b's light curve, the time axis, is what's causing all the hubbub. It took Super Saturn weeks to transit across in front of its parent star, 56 days to be exact. Planetary ring systems that we are familiar with in our solar system orbit right around the equators of the gas giant planets and are very thin, from only a few meters thick down to a few centimeters. In a telescope, Saturn's rings will seem to disappear when the planet is at zero inclination toward Earth. Saturn must be inclined at an angle in relation to Earth to see Saturn's beautiful ring system. It's something everyone should make a point of seeing: Saturn in a telescope. If Super Saturn's rings block most of the light from J1407 for 56 days, it means that the planet had to be orbiting at a steep inclination to its star. If it were at zero inclination, we wouldn't see the rings blocking any light. Therefore, the orbital time could be determined, 10 years minimum to 200 years if the orbit is highly elliptical. The superplanet itself is calculated to be 24 times the mass of Jupiter, which means that if it is gaseous, it could be a brown dwarf star. Super Saturn appears to have a Mars-sized object orbiting around it, because there is a huge gap in the rings that was most probably cleared out by a large object. The Cassini division in the rings of Saturn is where the moon Mimas has cleared out a path through Saturn's rings. The light curve of Super Saturn has only been observed once. All the exoplanet detection systems are keeping an eye out for it to come back around J1407. No one knows when that will occur. Some astronomers have suggested that J1407b is a brown dwarf star system in itself, merely passing in front of, but not connected to, star J1407. An orbital reappearance of Super Saturn would disprove that conjecture. The center region of Super Saturn blocked out all the light from its primary star. This is what indicates that the ring system is new and in an early developmental phase. Over time, the very dense ring mass close to the planet is expected to thin as all this matter gets absorbed into the planet or ejected into space. This is what has happened with our solar system's gas giant planets. The Mamajek object is a shocker. Never before or since has a light curve been detected like Super Saturn's. Super Saturn has added a new chapter to our understanding of the formation of ring systems. So, here's to you, Super Saturn. Hope to see you again soon. TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, I'm not going to say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler 70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you?
My mother.
WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you ask. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that Thumbworth. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. Now, Mercury is the planet that's usually closest to Earth. Does that surprise you? Did me. Venus certainly gets closer to us than Mercury. It can be as close as 25 million miles. After all, Venus is the second planet from the Sun, and Earth is the third. Even Mars gets closer to Earth than Mercury. The red planet can come as close to our home as 35 million miles, as it will in the year 2287. I won't be around for that. The average distance from Earth to Mercury is 48 million miles, but Mercury is still usually the closest planet to Earth. That's because Venus is usually somewhere on the other side of the Sun for 112 days, and Mars is usually far away in its highly elliptical, almost 2-year-long orbit. That leaves Mercury zipping between the Earth and the Sun every 44 days, and thus usually closer to Earth than either Venus or Mars. Hey, good trivia question to pull on your friends, isn't it? 22 spacecraft have successfully flown to Venus, and over 30 spacecraft have flown to Mars, but only 2 have ever gone to Mercury. So, what's so hard about going there? Well, it has to do with the Sun. Mercury is not only the planet that is usually closest to Earth, it is also the planet that is always closest to the Sun. 28.6 million miles close, to be precise. Being that close to the Sun creates navigational challenges, to put it mildly. Any spacecraft going to Mercury gets accelerated by the tremendous gravitational pull of the Sun. The spacecraft will be moving too fast to go into orbit around Mercury. That's why the first spacecraft that went to Mercury, the USA's Mariner 10, merely flew by Mercury 3 times, but made no attempt to achieve orbit around Mercury. The only other ship to go to Mercury, the USA's Messenger spacecraft, took 6.5 years to get there. Now that's a trip. Messenger did achieve orbit for a period of 4 years before finally running out of fuel and crashing onto the surface of Mercury on April 20, 2015. Many other spacecraft have flown to Jupiter in about the same time or less than it took Messenger to go to Mercury. The hang-up is the deceleration of the spacecraft. Quite simply, it takes too much onboard fuel supply to fire the engines in the reverse direction and brake the speed of the ship against the Sun's great gravity. Slowing down sufficiently to get into orbit around Mercury is a no-go using rocket power. Some other way had to be found to slow Messenger down, a way that didn't use much or any fuel. Messenger was a hefty 2,400 pounds or so, loaded with 9 pieces of state-of-the-art scientific equipment. Now, 55% of the total weight, or about 1,300 pounds, was fuel. But this fuel would not be used to slow the spacecraft down. The fuel would be used for 5 engine burns associated with gravity assists and also for orbital adjustments once Messenger got to Mercury. Now, gravity assists uses the gravity of a planet and the planet's orbital velocity to either speed up or slow down a spacecraft. If the ship approaches a planet at a forward-moving angle, that is, an angle in the direction the planet is revolving around the Sun, then both the planet's gravity and the orbital velocity of the planet give the spacecraft a slingshot boost, greatly increasing the speed of the craft and sending it off in a different direction. This boost in speed can be added to by the spacecraft firing its rocket engines at just the right time. Both of America's Voyager probes use Jupiter's massive gravity to slingshot them to the outer gas giant planets and eventually out of the solar system. Gravity assist can also be used to slow down a spacecraft, as in the case of Messenger. By entering a planet's orbital path ahead of the planet's gravity pulls back on the spacecraft and slows it down. An engine burn is necessary at this time to escape the orbital path of the planet. Messenger performed 1 gravity assist flyby of Earth, 2 gravity assist flybys of Venus, and 3 gravity flybys of Mercury. Only then had Messenger been slowed enough to enter into orbit around Mercury. The probe traveled an astounding 5 billion miles to get to Mercury from Earth. That's farther than Pluto is away from Earth at its most distant. The name Messenger is an acronym, almost as clever as its intricate flight path to Mercury. Because Mercury is the fastest-moving planet, the ancient Greeks appointed Mercury as the messenger of Olympus. News traveled fast even back then. MESSENGER really stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. What do you think? Did they have a contest to come up with that? Now, the good news is, there's another mission to Mercury underway right now. It is a combined ESA-JAXA space mission that is bringing 2 orbiting satellites to Mercury. The mission doesn't use an acronym for its spacecraft, it has a real name, Bepi Colombo. No, it's not a cartoon character. Dr. Giuseppe Colombo, after whom the spacecraft is named, was an Italian mathematician and professor of applied mechanics. He worked with NASA on the Mariner 10 mission to Mercury. Bepi is Giuseppe's childhood nickname, which everyone knew and loved him by. NASA had been content with 1 flyby of Mercury, the first ever, but Professor Bepi calculated that with a slight adjustment of the flight path to enable a gravity assist at Venus, Mariner 10 could fly by Mercury again and again on different orbits around the Sun. Thanks to Bepi, NASA got 3 flybys of Mercury for the price of 1. Bepi Colombo, the spacecraft, is scheduled to perform 9 gravity assist flybys, 1 at Earth, 2 at Venus, and 6 at Mercury itself. Each planetary deceleration slows Bepi Colombo relative to the speed Mercury is moving around the Sun. This will allow for orbital insertion. Otherwise, Bepi Colombo would head off into the Sun. Now, once in orbit around Mercury, Bepi Colombo's Mercury Transfer Module, or MTM for short, will release 2 satellites, 1 European, the MPO, Mercury Planetary Orbiter, and 1 Japanese, the MEO, Mercury Magnetospheric Orbiter. Both are expected to orbit Mercury for 1 year. Altogether, the MCS, Mercury Composite Spacecraft, consists of the MPO, the MEO, the MTM, and MOSIF, which protects the spacecraft from the Sun and houses the electronics for MEO. This alphabet soup of mission components highlights the other reason it is difficult to get to Mercury. After 6 gravity assist slowdowns, 6 engine burns, 18 orbits around the Sun, 6.5 years of travel time, and 9 billion miles of distance, you have to bring a tailored complex of equipment. It's like that mountain picnic you'd like to go on. You can't just drive there. You have to hike a long way up a tricky mountain trail and bring along insect repellent, sunscreen, and your hat. Oh, and lunch and beverages. It's not easy. Bepi Colombo has packed it all, including lunch. Nah, not really. The design is incredibly complex. Nothing can face the Sun, not even the solar panels. The solar panels must be kept turned almost to a right angle to the Sun, or the heat and particle flux will corrode the solar cells, and without electricity, you have nothing. Therefore, at right angles to the Sun, the solar panels must be extra long, as if there were only a little bit of sunshine. Bepi's solar panels are 50 feet long. The sun shield must remain gyroscopically aligned towards the Sun so that all instruments are always in the shade but still have a line of sight to what each is meant to monitor. And there are a lot of instruments, 5 in the JAXA orbiter and 11 in the ESA orbiter. It's one amazing picnic. Anyway, the science objectives are meant to add to what we have learned from the previous 2 missions to Mercury. The data collected by Bepi Colombo will enable scientists to study the planet's interior and composition, along with Mercury's geology and surface morphology, Mercury's magnetic fields formation and evolutionary history, the planet's solar-wind interactions, and overall environment. As a metal-rich planet, Mercury may hold a vast wealth of minerals that MESSENGER failed to detect. Bepi Colombo launched in October 2018 and still has a long way to go before it goes into orbit around Mercury. However, Bepi has already flown past Mercury and returned new photographs. The European Space Agency is excited about its first hot mission. All of the ESA's previous missions have been cold missions to objects further out into space, such as Mars, the asteroid belt, Comet Rendezvous, and elsewhere far out in the solar system. Well, all I can say is, best wishes to Bepi Colombo. Let's hope all goes well on its 800 degrees Fahrenheit mission to Mercury. Let's hope that Mercury's long tail of exosphere gases, sodium, magnesium, and potassium, blown off the planet's surface by the solar wind, don't fog up the lenses or coat the solar panels. Have a nice time! Ciao, baby! Dark, mysterious, cold space. Comets, asteroids, planets, stars, and something that's lurking over there, far beyond Pluto. Yup, this could be the 9th planet of our solar system, the one people have been wondering about for centuries. IRAS, which stands for the Infrared Astronomical Satellite, collected interesting data back in 1983. It could be proof that Planet 9 is hiding there. No one knows if it really exists, but this discovery helped to build a model to understand this potential planet better. And in 2016, scientists found out that some small space objects in the Kuiper Belt were orbiting a bit oddly. The Kuiper Belt is the outer area of our solar system. It's a ring in the shape of a donut, filled with leftovers from the times when our solar system was forming. You can find this donut beyond Neptune. The objects in that region of space have weird orbits, almost as if a big body with strong gravity is pushing them away. Knock knock, Planet 9 again. The theory says it might be 5 to 10 times the mass of our own planet and up to 20 times further away than Neptune. The astronomical unit equals the distance between our planet and the Sun. Pluto is approximately 40 astronomical units from the Sun, but Planet 9, if it exists, is 400 to 800 astronomical units away. It would take 10,000 to 20,000 Earth years for this mysterious planet to make a single circle around the Sun. This makes it harder for us to catch this space body. There's a theory Planet 9 may have formed between the orbits of Jupiter and Neptune, similar to the rest of the gas giants in our solar system. The gravitational force of one of the two huge planets probably kicked it out of its orbit. Oh no. Then Planet 9 could get ejected further away from the 8 planets we know about. It ended up as some sort of icy waste, quite small at the beginning. But as time went by, Planet 9 has cleared its orbit of frozen pieces of rock and dust and finally formed into a real planet. Another theory says that this could be a planet another star lost on its way while it was passing near our solar system. In any case, Planet 9 probably doesn't reflect that much sunlight since it's so far away. And astronomers aren't sure where exactly they should look for it. Space is dark, mysterious, endless, obviously. But if we do find Planet 9, it will be the first solid proof there are more planets in our solar system than we thought. Moving on to an interesting exoplanet, located only 90 light-years away from us. An exoplanet is generally a planet located outside our solar system. This one has an atmosphere with water clouds. 1 year there lasts 24 Earth days, and the planet travels around a red dwarf star, which is way dimmer and smaller than our Sun. That's why, even though the planet is 8 times closer to its star than we are to our Sun, the temperature there is similar to that on our planet. This exoplanet has a size similar to Neptune. It's also less dense, which means it's mostly made of gas, unlike Earth, which is made of rock. The average temperatures there is 140 degrees, which makes it one of the coolest small exoplanets we've ever discovered. And the cooler the exoplanet is, the bigger the chance we'll find clouds in its atmosphere. Researchers have discovered more than 4,000 exoplanets, but all of them have been found within the Milky Way, at least until now. For the first time, astronomers may have spotted a planet outside our galaxy. They called it M51 ULS-1. The planet is located in the Whirlpool Galaxy, a distant spiral galaxy 28 million light-years away from us. There was once a huge but pretty young star that got stuck in a gravitational dance with something that could be a dense neutron star, the collapsed core of a giant star, or a black hole. The star's dance partner had incredibly strong gravity. It was feeding on the star, greedily ripping away its plasma. Then something unusual happened. An unknown, maybe even Saturn-sized object passed by and blocked this confrontation from our solar system. Now, no one can see what is going on. But this could potentially be the farthest planet we've ever discovered. There's a newly discovered planet outside our solar system. As large as Jupiter, it orbits 2 stars. And, as we can observe it from our planet, it crosses in front of them both. The full circle around these 2 stars, which means 1 year, takes approximately 200 Earth days. On the day of the discovery of the previous planet, scientists also found it had an unusual companion. It's an extra-hot Jupiter with an ultra-tight orbit around its star. The year there lasts only 1.9 Earth days. This planet has a weirdly shaped orbit. Also, it travels in the opposite direction from the rotation of its star. If you could travel 57 light-years away from our planet, you'd see something pink lurking in the darkness. As you get closer, it becomes bigger and more fascinating. Yup, it's a magenta-colored planet. A few billion miles away from its sun, this guy is one of the youngest planets scientists have discovered. It's only 100 to 200 million years old. It's made of pink gas, similar to our Jupiter. So, if you could fly closer to its surface, this gas would envelop you like a thick fog. You're coming closer and going deeper, and the gas is becoming darker, getting a reddish shade. And look at the planet's core. It's super hot. Because of its high temperature of 460 degrees Fahrenheit, this planet is like an oven. The heat is the reason the planet glows so brightly. You'll also notice the sky is hazy pink, with clouds made of droplets of frozen water, similar to ours. There's another exoplanet half as massive as Earth, which is one of the smallest planets we've ever found outside our solar system. It has a diameter of 5,600 miles. For comparison, Earth's diameter is 7,900 miles. The planet in question is mostly made of iron, similar to Mercury. Mercury has a massive iron core and a very thin crust, which makes it an oddball in our solar system. At its early stages, it collided with some space body at least once. That collision pulled its outer layers away, which is why only the firm iron core remained. Maybe this exoplanet participated in a huge space crash too. That's what probably took away the planet's mantle and left mostly its iron core. Or maybe this is just a remnant of a gaseous planet that used to be the size of Neptune. The atmosphere of the planet could be blown away by, let's say, a huge amount of radiation coming from the star. This planet is only 31 light-years away from us, and the day there is less than 8 Earth hours long. The planet is only a little bit bigger than Mars. People aren't likely to ever settle in that place because of its extreme temperatures that go up to 2,700 degrees Fahrenheit. There might even be molten lava on the side of the planet that faces its star. Such temperatures are high enough to evaporate any atmosphere, so this planet might have had one in the past. Generally, gas giants like Jupiter can't support life because they have extreme weather conditions, temperature, and pressure, and there are no building blocks that might create life. But smaller terrestrial planets, such as, Earth, have more key ingredients like oxygen and liquid water. Plus, they have more temperate weather and other conditions. And still, not all of such planets support life, of course. It's not easy to find a planet with similar conditions as the ones we have on Earth, or at least the conditions that would allow life to develop there. But meet Kepler 22b, one of our most promising findings. It's 600 light-years away from us, twice bigger than our planet, and with temperatures of about 72 degrees Fahrenheit. This is a so-called super-Earth. It's a category of planets unlike any we have in the solar system. They're more massive than Earth, but still lighter than ice giants such as Uranus or Neptune. Super-Earths can consist of rock, gas, or a mixture of these two. Kepler 22b is within the habitable zone of its parent star, which is less bright than our Sun. The planet probably has a rocky core. It may have an ocean, but it doesn't host any life. At least, we don't know about it yet. While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits. and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical 9th planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Badigian have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry, they say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigian's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there.
This planet is as light as a piece of fluff stuck to your sweater. In the scientific world, it's called WASP 193b, but we'll call it the Cotton Candy Planet. It's located around 1,200 light-years away from us, so we'll never see it with our own eyes. It has an extremely low density, which combines with other features, like its high temperature and the infrared brightness of its host star. And all this makes it really special. Interestingly, the planet's radius is 1.46 times the radius of Jupiter, but its mass is a mere 0.139 times of our gas giant. May I have a close-up here, please? Thank you. See how fluffy it is? It would be absolutely impossible to stand on its surface should you ever reach this distant world. It's not often that you can meet something like WASP 193b at a planetary party. Such planets are rare. Their fluffiness might be caused by their parent stars. Those heat them, puffing them up like a marshmallow that's seen too much campfire action. The planet's super low density makes it a real anomaly among those 5,000 plus exoplanets we have already discovered. The thing is, if you're that close to your star, and mostly made of a hydrogen-helium cocktail, you're not going to keep your puffiness for long. It's like trying to hold onto a balloon during a hurricane. A world similar to this would look puffy for a few tens of millions of years, not more. while the star is very young and hot. But here's a problem. The star our cotton candy planet orbits is estimated to be around 6 billion years old. By no means is it young. Potentially, there could be some mechanism for internal heat puffing up the atmosphere of the planet. But the properties astronomers have observed can't be recreated even with the help of complex planetary evolution models, even under the unrealistic assumption of a coreless structure. It makes WASP 193b a true cosmic mystery, and solving it will require more theoretical and observational work. Gas giants which are close to their host stars are great for observation. According to our understanding of planetary formation, even though they had to have formed within their home star system, it still happened further away from the star. And then they migrated inward, closer to the star. Our cotton candy planet orbits a sun-like star named WASP 193. This star is about 1.1 times the mass and 1.2 times the radius of our sun. Plus, it's very close to the sun in age and temperature. But the cotton candy planet travels much, much closer to its star than any of the planets of the solar system. It zooms around it every 6.25 days. Exoplanets like this fluffy guy here are pretty rare, but there's also WASP 107b, and it looks squishy too. This one kicks back 200 light years from us, and it chose the constellation of Virgo as its official residence. From some perspective, you might say that this planet has something in common with our Earth. It has helium, and its atmosphere contains sulfur dioxide. There's some resemblance for sure. But WASP 107b has the density of a marshmallow. It means we can snoop through its atmosphere easier than we could with a heavyweight like Jupiter. Scientists were beyond surprised when they peered through their super space goggles, the James Webb Space Telescope's MIRI-CAM. They spotted clouds made of the stuff that builds beaches, silicate, or, as you might know it, sand. Imagine sand castles in the sky.
Perhaps one of the most perplexing aspects of our solar system is the fact that not every planet is a lovely solid sphere like our Earth. Some are almost entirely made of gas. If you visited Jupiter, you wouldn't be able to stand on its surface. You'd likely fall through its gaseous layers, all the way down to the planet's core. You'd have to survive an incredible amount of pressure before hitting its potentially rocky core. Whatever the case, mysterious gas orbs have always intrigued scientists. Luckily, now they have the James Webb Space Telescope to satisfy their curiosity. The incredibly powerful infrared eyes of this instrument see much more than what the telescopes of the past could spot. And recently, a team of researchers announced they may have noticed something interesting about the dynamics of gas giant formation. All thanks to James Webb. Soon, we might be able to answer how long gas giants have to form around their parent stars before all the gas around those stars fades away. At the moment, it seems like this period of time isn't too long, but there are some nuances. The team used the Webb telescope to probe the disk wind. This name doesn't really refer to any kind of wind. Instead, it refers to the process of gas leaving a disk around a star. The so-called disk, also known as a protoplanetary disk, is filled with various stuff and has the potential to give birth to planets. Astronomers knew such disks existed and could play an important role in disk evolution, but they couldn't figure out the underlying physics or estimate how much mass was lost in the process. Now, they might be able to do so. The wind disk studied by the team seems to move at a rate of 6 to 9 miles per second, which is quite slow for something moving in the vastness of space. Fast-moving gas patterns, known as jets, can boast speeds of more than 62 miles per second. The researchers haven't come to any specific conclusion about how long gas planets have to form before depleting protoplanetary disk gas completely, but based on their preliminary calculations, it might take about 1,100 years. Even though it sounds like a really long time for us Earthlings, in astronomical terms, it's an incredibly short timescale. For comparison, a protoplanetary disk can live for 5 to 10 million years. One of the main difficulties in examining disk-wide movements is finding a protoplanetary disk. But our solar system doesn't have any. All our planets are formed and complete, including gassy ones. That's why the team found another target, a disk around a young, low-mass star called T-Chi. This star, lying 350 light-years away from Earth, is quite interesting in its own right. It has a large dust gap in its disk. It's thought to be created by a planet or planets, consuming all the material on its way around the star. Such a gap may suggest that the star has budding planets orbiting it. It's also old enough for those nascent worlds to munch on parts of the disk itself. It might be what we know as the transition stage, moving from a protoplanetary disk to a solar system-like structure. So, the perfect disk subject was found. It was time to track some neon, a peculiar gas great for disk exploring. It's one of the gases that are more likely to exist in protoplanetary disks. Plus, neon spits out electrons at pretty modest temperatures, which makes it easier to spot. After examining the region with the help of the JWST, scientists concluded that neon was indeed coming from further away from the star. But that was not all. Along with neon, the team found argon. It has been seen in several protoplanetary disks before, but its traces have never been this strong. Some senior researchers thought it wouldn't be possible to see them so clearly, but thanks to James Webb, and after vigorous tests, the results were confirmed. These results are a small but crucial step in understanding more about the mind-boggling nature of gas planets.
At the edge of our solar system, there's a cold and mysterious region known as the Oort cloud. It's a hypothetical vast area of icy space objects surrounding the Sun. It's believed to lie far, far away from our star, from 2,000 to 5,000 astronomical units. For comparison, Pluto's orbit carries the planet between 30 and 50 astronomical units from the Sun. And there, in this freezing emptiness, a rogue planet may be hiding right at the moment. At least, that's what new research has recently suggested. Rogue planets are called this way because they don't orbit around any star. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Rogue planets are usually kicked out of their planetary systems, doomed to a solitary existence of circling the center of the galaxy on their own. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. At the same time, there might be billions or even trillions of rogue planets wandering around our galaxy. If these estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Anyway, in 1907, one astronomer started a search for Planet X. It's a hypothetical giant planet moving around the Sun beyond the orbit of Neptune. The scientist was convinced that this planet existed because he had observed some irregularities in the orbits of Uranus and Neptune. His idea led to the discovery of Pluto in 1930. But the dwarf planet was too small to have any serious gravitational impact on the orbit of Neptune, let alone Uranus. These days, the Planet X theory is largely considered to be discredited, but it hasn't stopped astronomers from searching for planets in the far reaches of our solar system. And shockingly, a new study claims there might be one or even more out there, but much, much further away than predicted. An international team of scientists has recently simulated the unstable celestial mechanisms of the early solar system. They've discovered that there's a possibility that a few planet-sized bodies might have come to rest in the Oort cloud. You see, about 4.5 billion years ago, when the solar system was just forming, it was a hectic and unsettled place. Gravity sent debris from the cooling protoplanetary dust cloud hurtling around like cosmic tennis balls. From time to time, large chunks of this debris, even planet-sized ones, were sent flying far enough to escape the sun's gravity altogether. Such pieces of debris turned into rogue planets. Researchers have seen such space wanderers in distant exoplanetary systems, but according to them, there's a 0.5% chance that one or more of those wayward planets formed in the solar system and ended up in the Oort cloud after drifting away from the sun. At the same time, it's slightly more likely that a rogue, Neptune-like planet was snagged by the sun's gravity from another planetary system. And then, this planet came to rest somewhere in the Oort cloud. The chances that this scenario is true reach 7%. If this turns out to be the case, then a space body similar to Planet X might indeed be hiding out there, on the outskirts of our solar system. The only problem is that it would still be too far away to have any impact on Neptune's orbit. In any case, most researchers are convinced that the Oort cloud is made up of a collection of way smaller icy objects. But given the distance to the Oort cloud and its enormous size, we may never really figure out what is lurking out there.
There are 8 planets in our solar system, and they're all very different from one another. That's why, if one day they unexpectedly and inexplicably turned into humans, these people wouldn't look alike, and their characters would differ dramatically. Let's try to imagine what humans the planets of the solar system would make. Do you like our videos? Write about it in the comments, and please subscribe to our channel. Let me introduce Mercury. It's a curious and swift teenager around 13. 15 years old. He's always on the move and is a bit hard to pin down. He's into sports and tends not to walk but dash around. That's one of the reasons his knees and elbows are always scratched. He's just like the planet Mercury with all its countless craters. Now, meet Venus. It's a beautiful young lady in her mid-20s. She likes to keep her secrets, and her alluring beauty comes with a temperamental side. At parties, she easily attracts attention because of the mystery surrounding her. But those who dare strike up a conversation with this beauty soon realize that she's scorchingly direct and doesn't tolerate nonsense. Earth is in her late 20s. She is very pretty and extroverted, and has a nurturing, balanced personality, forever the peacemaker, trying to maintain harmony. Earth is the one everyone turns to for advice and comfort. She has a pretty unusual hobby, collecting different life forms, like someone who always brings home stray animals. And if she feels that something or someone is a threat to her beloved pets, she can get furious. Mars is a cool guy in his early 20s. He's ginger and sturdy. He's that ambitious and a bit annoying younger brother, living in Earth's shadow. But he doesn't give up and is determined to make a name for himself. He's a great fan of adventure and exploration, that very type who enjoys camping, wilderness, and slightly dangerous activities. His guilty pleasure is Googling stories about ancient warriors. Jupiter is in his early 50s. He is that protective elder with a bigger-than-life personality. He is a respected head of a large family, known for his wisdom and jovial nature. He also loves to throw big parties that sometimes get out of hand. Saturn, an elegant lady in her late 40s, is stylish and timeless. She is always the best-dressed person at any gathering. She's known for her beauty and has a calm, sophisticated demeanor. She loves accessories, especially elaborate rings. She's got quite a collection. Uranus is in his late 30s, and he has an unconventional, quirky personality. If you have a problem and need a different perspective on something, he's the one to go to. No wonder his planet counterpart has a unique axial tilt. Uranus isn't afraid to be different. He enjoys innovative and boundaries-pushing art, and some suspect he might be a hacker. Neptune is a thoughtful man in his early 40s. He's kind of a dreamer and probably the most creative one in the group. You can often find him lost in thought or swept away by music. He's almost always wearing his large blue headphones. He's very sensitive and has a high emotional intelligence. This quality draws others in. That's not all. Let's look at a space body that used to be a planet, Pluto. It's a very young teenager, quiet and often overlooked. But he has a surprising amount of depth. Despite his introverted nature, he has a group of close-knit friends. It might take time to get to know him, but those who gain his trust discover his different side, endearing and witty. The Sun is a big boss. No one knows how old he is because he looks ageless. Rumor has it he frequents beauty clinics, but shh! The Sun knows his worth and uniqueness. He's quite caring and nice to his subordinates, but he's also rather hot-tempered, and when he gets angry, he expresses his displeasure openly, often by throwing stuff. The Moon is a shy 18-year-old girl. It's hard for her to make new friends. She prefers to keep close to the only friend she has, which is Earth. To her, Earth is a motherly figure who can protect and give valuable advice. The Moon has some skin problems, which also makes her feel rather insecure. But don't worry, Earth is working on her confidence. When watching a beautiful sunset over the sea and in the mountains, have you ever thought about what a sunset on Mars looks like? Or on Venus? Do they have the same reddish hues as sunsets on Earth? Not really. You see, sunsets look very different on different planets because of the composition of their atmospheres. Sunlight scatters off of the molecules that make up an atmosphere. This process is more effective at shorter wavelengths, which is the blue end of the visible spectrum. That's why we perceive the sky on our home planet as blue. But at sunset, light needs to travel longer distances through the atmosphere. That's why we see yellow and red hues. Now, let's move to Mercury and check what sunsets look like there. Both sunrises and sunsets on Mercury are views to behold. The Sun seems 2.5 times larger in the sky over this planet than when you look at it from the surface of Earth. It also rises and sets twice during a Mercurian day. It rises, arcs across the sky, stops, moves back to the rising horizon, stops again, and restarts its way toward the setting horizon. Such bizarre maneuvers occur because Mercury rotates 3 times for every 2 orbits around the Sun, and its orbit is extremely elliptical. But if you expect to see a blazing sky and the hues of red, you'll be disappointed. Mercury has almost no atmosphere, so its sky is always black since light doesn't get scattered at all. Let's continue our journey and go to Venus. There, at sunset, a bright yellow fades into orange, brown, and then when the Sun disappears, black. The planet rotates on its axis very slowly, so to see a sunset, you'd have to wait almost 1/16 times as long as you would on our home planet, half of a Venusian year. Mars is widely known as the red planet because of its rusty color caused by the presence of iron oxide in its soil. But sunsets on this planet would look surprisingly blue if you watched them from the surface of Mars. Fine dust in the atmosphere of the planet scatters light and makes the blue hues around the Sun's area of the sky brighter. A Uranian sunset is azure, fading into royal blue with some hints of turquoise. The pretty colors come from the interaction of sunlight with the planet's atmosphere, which mainly consists of hydrogen, helium, and methane. These gases absorb the longer wavelength red portion of the light, and the shorter wavelength blue and green light gets scattered when photons bounce off the gas molecules and other particles in the atmosphere. In 2014, scientists working with data received by NASA's Cassini mission showed what a sunset on Titan could look like. The largest moon of Saturn is surrounded by haze and smog. It's the only satellite in the solar system with a measurable atmosphere, which mostly consists of nitrogen, around 95%, and methane, about 5%. High in the atmosphere of this moon, the nitrogen and methane get split apart by the ultraviolet light from the Sun and high-energy particles accelerated by Saturn's magnetic field. The compounds produced during this process create a thick, orange-colored smog. As the Sun sinks toward the horizon, these orange hues turn into a deep brown. Now look at this. It looks like a sunset on Earth, right? But it might actually be what it looks like on Saturn. We have to say might because, just like all images from space, we can rarely get the color right. They are neither true nor false. They just represent the physical processes underlying the subjects of the images. As for the photo of a sunset on Saturn, it's hard to say if it looks exactly like this before we get more scientific data. As we venture deeper into cosmic exploration, we encounter a plethora of exoplanets that defy our Earth-centric notions of what a planet should be like. From pitch-black gas giants to planets being torn apart by their own stars, these strange worlds offer a sobering glimpse into the extreme and varied conditions the universe harbors. In this overview, we delve into some of the most peculiar, hostile, and enigmatic planets known to humanity. Tres 2b. Located in a remote corner of the universe, Tres 2b is a world where darkness reigns supreme. Forget a sky filled with twinkling stars or even the barest sliver of a moon. Here, it's an abyss of darkness. This gas behemoth is 1.5 times more voluminous than Jupiter and possesses an uncanny ability to absorb light even more efficiently than charcoal. It's a place where photons go to die. Its atmosphere, torrid and choking, may occasionally display a dark ruby-red hue caused by air heated to temperatures similar to molten lava. It's a world that flips our understanding of night sky on its head. 55 Cancri E. Within the 55 Cancri system, a peculiar hellish world orbits its star in an uncomfortably tight dance. 55 Cancri E is subjected to such intense heat that half of its planetary face has become a seething ocean of molten lava. Picture an entire hemisphere ablaze, a burning sea without end. The other half is a perpetual desert of darkness, never touched by the light of its nearby sun. And between these two extremes lies a narrow band of perpetual dusk, where twilight lasts forever. The stark contrast between the burning and the desolate creates an eerie landscape of hopelessness. HD 189733b. At first glance, you'd think HD 189733b is an artist's impression of an alien ocean world. Its surface appears to be beautifully patterned with swirls of blue and white. But this beauty is deceiving. Those captivating patterns are the result of silicate particles in the planet's turbulent atmosphere, which conspire to create a storm of glass rain. That's right, glass shards falling from the sky, propelled by winds reaching speeds of 5,400 miles per hour. Anything and everything in its path would be ripped to shreds in moments. PSRB 1257 plus 12. Imagine a place where your very atoms are torn apart. That's what is happening to the planets in this system, thanks to their parent star, a pulsar. Pulsars are the remnants of exploded stars, and they release potent electromagnetic pulses. These energy bursts are gradually erasing the existence of the exoplanets in this doomed system, breaking them down at an atomic level. Their fate is to slowly dissipate into the cold void of space. Kepler 70b. Once upon a time, Kepler 70b might have resembled Jupiter, a gas giant enveloped in a thick atmosphere. But its parent star went through an explosive midlife crisis, expanding into a red giant and gobbling up Kepler 70b in the process. Now, this planet is a fiery rock with temperatures that exceed those on the surface of the sun. The extreme heat is causing the planet to evaporate. Its days are numbered. WASP 12b. Tragic might be the most fitting word for WASP 12b. Its massive parent star is pulling it into an oblong shape, reminiscent of an egg. As it spirals closer, the gravitational pull becomes even stronger, signaling an inevitable fatal attraction. In a cosmic time frame, WASP 12b is already on its deathbed. Gliese 436b. Imagine a world so contradictory that it boggles the mind. Gliese 436b is both scorching hot and eternally icy at the same time. Despite being hotter than an oven, its surface ice doesn't melt away. Instead, it burns continuously due to the planet's intense gravity, which keeps it solid. Venus, our neighboring planet, is another nightmarish world. With a hellish atmosphere, corrosive sulfuric acid rains, and surface temperatures that even outstrip those of Mercury, it is truly Earth's evil twin. Dimidium is another inhospitable planet, tidally locked to its star. One side is scorched at temperatures exceeding 1,800 degrees Fahrenheit, while ferocious winds of 600 miles per hour sweep the surface. This gas giant even experiences molten iron rain. Can a planet be bigger than its parent star? Well, if you mean a star like our Sun, it's highly unlikely. But what if it was a white dwarf, the remnant of a star similar to ours that went out after shedding its outer layers and leaving behind nothing but the core? This core is what we call a white dwarf. Usually, it's around the size of our home planet. If a star had a planet bigger than Earth before it extinguished, it's possible that such a planet could survive all the chaos. In this case, a planet that is bigger than its star might actually exist. And we've even found planetary systems like this. But there's one problem. A white dwarf isn't a real star like our Sun anymore. It doesn't produce energy, just sits out there getting cooler and cooler. So probably such systems don't count. For comparison, the Sun is working non-stop. It is fusing hydrogen into helium in its core. It has been doing it for more than 4 billion years and is going to keep doing it for the next 7 or 8 billion years. The Sun is 10 times as wide as the largest planet in our solar system, gas giant Jupiter. And sadly, you can't get a planet much larger than that. If you start adding mass to such a world, it will get smaller, not bigger. So it seems you can find a planet larger than the Sun. But there are also dim red dwarf stars. They're the smallest out there, barely massive enough to maintain fusion in their cores. The tiniest stars that we know about have been discovered recently. If astronomers' conclusions are correct, then both of them can hardly fuse hydrogen into helium. And it takes about 0.077 times the Sun's mass, or 75 masses of Jupiter, to be able to do that. And still, they're real stars, just very tiny, smaller than Jupiter. One of them is only about the size of Saturn, which must mean that stars can have planets bigger than they are, right? Well, theoretically. When it comes to practice, you can hardly find such planetary systems. We've found and observed quite a lot of exoplanets, which are worlds orbiting other stars. It seems that there are indeed loads of trends out there in space, different masses, sizes, brightness, and so on. But the main trend? Red dwarfs don't usually have gas giants orbiting them. If they do have planets, those are typically small, rocky worlds, more like Earth. Those are also called terrestrial planets. For example, a red dwarf called TRAPPIST-1 has 7 Earth-sized planets orbiting it. But gas giants circling around red dwarfs are extremely rare. Hardly 1 in 100 tiny stars can boast such a planet. This number can be even smaller since the research has been done using candidate planets which haven't been confirmed yet. Plus, the smallest stars are also the dimmest. It means they are extremely hard to detect, and it's incredibly hard to figure out whether they have planets orbiting them, and if they do, whether these planets are gas giants or terrestrial worlds. Still, it's possible that a system where the planet is larger than its parent star exists. But the probability is statistically very low. At the same time, red dwarf stars are very numerous. They're actually the most common kind of star in the galaxy, making up around 70% of all stars. And even though really tiny red dwarfs are relatively rare, there still must be millions or probably even billions of them in the galaxy. And if there's even a small fraction of red dwarfs with gas giants orbiting them, it might still mean that a lot of such systems exist in total, and some of them can have planets bigger than their host star.